4271. And for those who can see the chat, I'll also pop the link in as well there, so you can hopefully just press straight onto the link.
Sorry,
People will be delighted.
Can you just repeat that medical, because I can't see the chat and I missed what you said.
Okay, I will say it again, and I can. That's my friend Claire. I recognise that voice anywhere. So just for Claire and anybody else who didn't hear it, so the code is 8884 4271.
Thank you.
That is my absolute pleasure. Okay, well let's get us started for today. Sometimes I'll try and make it easier for the video editors. So I will start now. Good morning, everyone. In today's Midlands Analyst Network Huddle, we're going to be talking about complex IT or complex IT. I forgot to ask Brian. Enabling non-experts to leverage advanced computational modelling for policy evaluation and decision making. And that is with Brian Castellani, who I'm going to be introducing you to shortly. But before we do, I'll just remind you who I am. Just in case you don't know, I'm Rachel Caswell, and a very, very warm welcome to your Midlands Analyst Network Huddle. And for those who don't know me, I'm an analyst in the strategy unit, and I also lead the Midlands Analyst Network and the strategy unit training and development. So, quick reminder, why do we have these huddles? For any new people and special guests, and of course all of our existing huddlers, we hope you'll find these fortnightly huddles useful by sharing skills and learning from each other's skills and experience. But I hope you'll find these are just a really fine place to hang out and an opportunity to meet others, other like-minded analysts who work in and around the Midlands. We have many people who are not in the Midlands, so we welcome them as well. I would like to find the information I want to share with you, but before I do that, let's just go to Menti and see what we have waiting for us there. I can see lots of people are already there, so I will zoom straight into oh well, look at that, what a lovely image. As you can see, I am bestowed in a sparkly Christmas jumper today. I've really made the effort. I've properly, well and truly stolen my daughter's jumper for the occasion. And I have a question for you about Christmas trees, of course. I'm interested, as I am this time every year. What indeed is your Christmas tree status? These are very important questions for you and totally irrelevant to the topic in hand. But let's just get a feel of where we're feeling in terms of that build up to Christmas and Christmas spirit. Christmas may not be your thing. And it's indeed it is not the thing of many people here. So you might recognise the picture in number 2. That is, of course, Trafalgar Square, finest Christmas tree ever. Had a little bit of interest, I think, from the media, saying that it wasn't up to scratch, but it's pretty tall, looking rather lovely with all its lights on. Okay, so we have a lead between it's up and looking rather fine and not my thing. Excellent. And for the benefit of Brian and others, if you'd just like to say who's in the room now, who do we have who's going to find out more about this topic? So what's your name? And if you just say what your role is, and we can just take it from there. So I'm Rachel. I'm an analyst, but I do all sorts of other things as well in the strategy unit. So we have an analytics manager. Hi, Josh. Hi, Andy. Hi, Mike. Public health practitioner, BI developer. Hi, Jenny. I know you. We have an analytics manager, Ivan. Hi, Sarah. It's probably Sarah times 2, as we found out before. Hi, Claire. Hi, Mike. And we have the analyst community dominating there in the middle, as you would expect in the Midlands Analyst Network. And thank you for all joining in on this as well. Okay, one other question for you before we hand over to our guest today. If you'd just like to say what organisation that you work for, so we can see what the spread is today. I have colleagues from the strategy unit, always lovely to see you. We have acute hospital represented, CSU, local authority, a mental health provider. That's interesting. So each week we have new people joining the Midlands Analyst Network. So it's good to see that we're getting most areas covered in this as well. Okay, so I will thank you for doing that. I'll leave this up, which is about a place for you to ask questions for Brian. If you can't see the chat, of course, you can use the chat if that is available to you as well. And I would just like to say a couple of words about Brian before I hand over. Slightly distracted with my daughter going in and out the front door. She keeps forgetting things. So our guest today, I'm delighted to introduce you to our guest today, who's Brian Castellani. Brian is a professor in social and public health. He's a director at the Durham Research Methods Centre, director Wolfson Research Institute for Health and Wellbeing at Durham University. Brian's also adjunct professor of psychiatry at Northeastern Ohio Medical University, and Brian has worked for over 10 years in healthcare as a clinical psychologist and continues to work in healthcare with healthcare providers and in public health. So Brian's also published several books. I've been nosing around his website and finding out more about what he's been up to. And I think the most recent one is the Atlas of Social Complexity, which looks absolutely fascinating. But without further ado, I would like to hand over to you. Brian, you're very welcome.
Thank you, Rachel, and thanks also to Mohammed and Jennifer for initially having an interaction that led to this presentation. So yeah, as you said, my background is in healthcare. So even though I'm an academic, my work has always been with that other hat on of practitioner and thinking about public health, thinking about healthcare practice. So probably about 15 or so years ago, my colleagues and I started really developing new ways of using computational methods, computational modeling for policy evaluation. For those who may not be familiar, you can check it out at Surrey, University of Surrey. We have CCAN, which stands for the Center for the Evaluation of Complexity Across the Nexus. And we got quite heavy into, it was an ESRC grant, large center grant, around how to do evaluation that not necessarily is about whole systems mapping, but about evaluation that takes into account the fact that any intervention, no matter how simple, say within the NHS, is always taking place within a wider complex system. And so how do you understand these, what are ostensibly qualitative relationships amongst factors? So for those of you who don't have a background, particularly in computational approaches, AI or these sorts of methods, they're neither statistics nor are they qualitative. They sit in their own interstitial area, given that they're algorithmic driven. So after publishing a handful of articles in journals like Physica A and so forth, and realizing nobody was going to use these methods, citations of 2, 0, 3, we realized we needed to get these tools in the hands of people that don't necessarily have expertise in them, but are quite keen to use them. There's a very famous physicist, some of you may know, Duncan Watts. He's the originator of the concept of 6 degrees of separation, and his mentor, Stephen Strogatz. Watts wrote an article for the Annual Review of Sociology, and he said that physicists are very good methodologists, but they're horrible theoreticians. Social scientists lack the training that physicists have, but they're really brilliant at understanding the empirical realities of what they're working on. And so even today, I'm going to show you this platform, but it really is about, not even if you're not keen on these ideas, being aware of them and engaging them, because the individuals, as a lot of the policy or folks in the room know, will and are using these things, but not necessarily with the type of knowledge that a lot of us bring from a social sciences or health or even humanities background. So with that said, I'm going to show you this software package, and then we can kind of go from there. So this is called Complexit. I had Rachel share the link with most of you. It's a freeware package that you can use either as a web version or as a downloadable for those of you who use R. I also provided to Rachel to send out a copy of one of the chapters in the Atlas of Social Complexity that explains this case-based complexity approach. And I have in there, you'll see, please don't share with others. So I'm sort of, not supposed to be sending that chapter out, but the heck with it. It's out there, and please read it, and I think it will be useful. You'll see first, just a quick before we jump into the actual software itself, that the Complexit framework has a series of tutorials that you can explore that allow you through each tab that the environment functions within. You can go in and learn about it. We've got PDFs, exemplary data sets, and some pretty low-grade YouTube videos that I've done, which people have found, interestingly enough, enjoyable. I've done some more professional quant, and they said we sort of like the basement versions that you have. And then there's just lots more additional information. We have a wiki for the app as well, for those of you who are interested in this. You can actually use Complexit on your phone. It really is meant to be quite nimble and flexible. And a lot of it has to do with our colleague Corey Schimpf. If we sort of look at my team, who really was focused on the design environment. Corey's in engineering, but these are the team that are involved in the app development. But we really did try to focus on making sure that the app made sense. So we've really done an ethnography of the app as well, where we continually put it in the hands of people such as yourselves, see what's not working, what's working, what do we need to edit, what do we need to revise. So it's constantly in beta version. So that's the basic environment. So we're going to go into the web version of the software, and you can get a sense of how it works. So this is the introduction to the app. At each stage, you've got these small tutorials that give you information about how to work that particular environment. So, for example, the data sets need to be in CSV file format, which is just comma separated, which we went with specifically because everybody pretty much uses Excel. And this way you could, in most statistical packages, you can export as CSV or Excel files. So it allows for a certain global accessibility. I work with colleagues in South Africa and Japan and so on, basically around the world, and just trying to make sure. One of the things we've run into is the French Excel actually uses commas, so we've even allowed for different types of interfaces. So you'll see over here on the left, these are the tab environments. It starts with this opening part, which is to import cases and then begin to think about them. The key with Complexit, it is not supposed to be a button pushing enterprise. So even though it's part of this smart technology, a smart app approach, it really focuses on helping people not just learn about their data, but begin to learn about these methods. So we've built the tabs in a way that allows you, as you sort of learn how to read the tea leaves on this and begin to get a sense, you can actually get more sophisticated with the method. But even at the most basic level, the methods are quite rigorous. We actually used Complexit when we were modeling COVID for the Northeast. And so it is rigorous, and even at the entry level. So the first thing, obviously, is to get the data set up and running. So we'll do that. The data set that I've brought up here is from the Welsh Indices of Multiple Deprivation. There's this nice tab up here too, which allows you to shrink over so you can look at your data. So in this, most of you should be familiar with the various indices of multiple deprivation here in the UK. We've got lower super output levels over here, authority districts. First thing, obviously, we start with is just making sure the data makes sense. Is it what you're expecting? Are things in order and so forth? So here we have a series of factors that I pulled out that are related to the issue of underage conception rates in these various communities within Wales. So we've got, again, this is just for the purposes of simplification, but again, to show you multiple factors that could be intersected. A complexity approach, systems approach, very much allows you to look at the intersection of a variety of factors as opposed to a more the way I was initially trained to do sort of hierarchical regression analysis, partitioning out each factor for issues of multicollinearity and making sure you have true effect. Or this is more of a data mining complexity, Google sort of Amazon approach to life, which is profiling. So in this instance, we got first time in justice system, percentage or rate of teenage unemployment that are not in education, employment, or training, percentage of employment, first time offenders in the criminal justice system, percentage in fuel poverty, older adults in social isolation, and then underage conception rate, percentage of adults receiving NHS healthcare check, and then an overall deprivation average. So when I work with folks in the NHS or local councils or third sector, once we get the data up, the next step is to really ask them to think about how do these factors interrelate? And that can be a function of either the research you've done or your own expertise. And the way we do that is we start off right here by having them build a systems map of the topic that they're working with. This software package is by my colleague, Nigel Gilbert, which is brought into complexity. It's called PRISM, or the Participatory Systems Mapper. This software, it also comes with a whole series of tutorials and so on and so forth. But what's nice about this is everybody can enter in and swarm around this. Everybody gets their avatar. And when we're working together in groups, we just begin to build a systems model or systems map of the topic that we're trying to understand. So in this instance, we built this model in a workshop around this issue of teenage birth rate, looking at the factors that we have in the data set, and then how are they interrelated? How do they connect? And what's nice about this software package is it's quite simple to add different factors into the data set and put an example and then save and make these linkages and connections and really work around the framing of the model that you're trying to understand. Just to give you a picture of some of these things, these are examples that we've done variously on all sorts of different applications. Just again, to give you a sense of systems mapping here, we were mapping all the various work being done at Durham University around the issue of mental health and then building it into themes. This, let's see, this was another one where we looked at a healthy weight amongst adolescents in Durham County. And again, sitting down with Durham County Council experts and mapping out their understanding of healthy weight and the various factors that are impacting it. So that is where we begin, because the whole idea then is, for those of you who might be familiar with the Bayesian approach, really what a lot of complexity is about is data exploration. So it's not so much about what is happening, but what you perceive to be happening, which is so much about the world of policy, right? In other words, policy is about, we think this is what's going on, we make an intervention into it, and then we assess the quality of that intervention, which is Bayesian in the sense that you make the intervention, you got new information about relative degree of success, or alternatively a level of uncertainty, and then you adjust your understanding, change your intervention, and do it again. So right off the bat, we're trying to get the people we're working with to think in a more systems orientation, to think about the qualitative relationships amongst factors. And this brings life and insight into what is otherwise just a basic data set that we tend to start with these theoretical preconceptions in the background, but not necessarily flushed out in detail. So let me see here. So then the next step is to then begin the analyses once we've set up. So that takes us to this issue of clustering. So shifting in orientation, if you think about Amazon, Google, any sort of profile trending that takes place in the digital world, consumer profiling, whatever it is, profiling for tumor identification, patients at risk for some type of cardiac event, preparing for resilience around wintertime for bed accessibility, preparing for flu season, and so on and so forth. You're really talking about a complex set of factors that are associated with those different outcomes. The other thing too is that, as we know within the NHS, say what works in one part of the system doesn't necessarily mean it works in the other part of the system. So we have different types of outcomes. So this clustering approach is trying to think that way, right? So you've got a systems map, then the next thing you start to say, well, how do cases cluster together? So if you thought of a certain set of hospitals, or in this case, a certain area within Wales, of 28 counties that fit within this particular cluster and have this particular profile. And then 21, you see here size, 21 counties within Wales that have this particular profile. And so you see differences as you move across. These are called centroids. And it's basically just, as I said, a profile. And as you move along, we talk with folks about, do these profiles make sense? So if this were, say, a clustering of different hospitals within the NHS based on availability of beds going into winter and concerns about bed availability based on a set of factors around size of hospital, percentage of uptake on flu shots, jabs, whatever it is, you have that sort of information as these profiles for those areas. The nice thing, too, is we provide this in a visual way for those who don't understand necessarily how clustering works per se, but the idea of getting, this is called a silhouette plot, which allows you to pretty much look at each of the four clusters. In this case, we tried 4. And the more to the right, the better the fit. That's hence the notion of a silhouette. And we have average degrees of fit here, which again, when we work with people, we can take a look at how well are the cases fitting into each of these clusterings. Do they make sense? Is this a good profile? Is it a not so good profile? And again, I don't want to go too far down into the statistics. As I said, you can go in and watch the tutorials on how to do that. But there are lots of different little measures being provided for you as users to help you decide if you like the solution that you're after. Again, to remember that this is data mining. This is not traditional statistics where you have a hypothesis, you put in the data, you grind it out, and then you get a p-value and decide whether that's a good fit or not. This is really about data mining. This is about real-time engagement with your data and trying to get people to think better about the issue that they're struggling with, hence the Bayesian sort of thinking or complexity thinking. So we try various profiles. We can try 5 cluster solutions. Look, does that any better? We could go down to 3 cluster solution. I remember when I was in graduate school for clinical psychology, my advanced statistics professor said this is data fishing. And at that point we're not even talking about clustering. The world has significantly changed since then. These approaches are very much the algorithmic type of approaches driving a lot in the area of AI and large language modeling. And as I said, like cancer detection, detection of at-risk patients, for any sorts of events, and then so on and so forth. So it's a different way of thinking. The nice thing, though, for the statisticians in the room is at the very end of this whole process, sort of after you come through the funhouse of playing around with this, is you can download the report and you've got all the statistical information that's taking place in the background. Again, the idea here is really engagement with people who don't necessarily have to be experts, but the data heads in the room, they can get all the information here in the background, download the report, and run additional rigorous statistical analyses on it, run regression on your outcomes, build discriminant function analyses, growth mixture modeling, whatever you want to do for the statisticians in the room, you can do that. Alternatively, for the qualitative individuals in the room who do, say, qualitative policy analysis and so forth, one of the nice things about this approach is you can actually import qualitative data as well, as long as you can give it some degree of numerical assignment. There's a particular approach called QCA, qualitative comparative analysis, which works with what's called Boolean algebra, which is just sort of set theoretical sort of things. But yeah, you can bring in qualitative data as well. So at this part, it's really about getting the users to think about what it is that they're doing and what they think exists in the data set. They've built a theoretical frame, right? They've got some idea about how they think things look. We've got them to take the next step of thinking about the profiles and how they cluster. And now we turn to the machine learning. This is where we give the AI a turn. Part of the issue is, again, for the purposes of corroboration, you want to be able to say, okay, you've got this cluster solution, but really we do want to stay data driven. You're seeing the fit. Now let's let the artificial intelligence, this is a pattern recognition form of AI as opposed to large language modeling. And the goal here is to just, from a very semi-supervised perspective, what does that mean? We just give the machine a couple recommendations for how we would like it to run its analysis. But other than that, we get out of its way. And the nice thing is it's nothing more initially than pushing this button. But as you get more advanced, you can learn how to make changes in all of the various options here. What's nice then for the statisticians is finally we do get some F values and some P values. This particular approach to AI, I don't want to go too far in, but it's called Kohonen's self-organizing map. It's one of the few AI approaches that actually does let you look inside the black box. We've been quite amazed that it's not used more regularly by people, because right here, for example, it is actually telling you why it arrived at the solution, which we will look at in a minute. And you can see in here that deprivation average was the biggest pull for how it decided to sort all of these various communities within Wales. For any of you who know a bit about this algorithmic approach, algorithms actually are not smart. So everybody keeps saying, AI is going to take over the world. And my answer to that is we should largely be worried about that because AI is actually not particularly intelligent and it's incredibly lazy. It's just that it's so fast, it looks like it's amazing, when in fact it's not. A lot of AI is simply going for the easiest thing to sort, and then it becomes more nuanced with that as it goes along. But this interrelationship between what you've identified and what the machine identified is really what the game is about here. And again, I'm keeping this at a very light level, but you can definitely do a deep dive into all of this. The reason we put the tabs here is so that you can keep going back and forth and looking, okay, here's what we did, here's our solution. Okay, so what did the AI solution arrive at? And again, we try to stay visual as much as we can. This is, for those of you who might know, this is a hierarchical cluster analysis. In the cluster analysis here, this is called a k-means. It's sort of a brute force analysis that takes place, and as opposed to the hierarchical. Most people, a lot of people I talk to like hierarchical because it starts off treating every single case as its own cluster. Nobody's the same as me. And then ends with everybody's the same as me. And then the question becomes, what's the best fit along the way? So you can, one of the ways you can corroborate is we did a 4-cluster solution here. Now we can do another 4-cluster solution and see if that likewise fits well with the data. And again, I don't want to go too far into what this is, but it is a visualization and allows you to, I guess, this over here allows you to decide the proportion of variance that's being explained by the factor solution. So if you see here, the 4-factor solution, which would be right about here, these are the factors, the cluster solutions going up, gives you a sense of, is this a good fit? And then when do you enter what we would call a diminishing point of diminishing returns? But here's for visually where we start to move next. This is what's called a SOM grid. What is very useful about this approach to clustering is that it visualizes the cluster solution on a 2-dimensional or potentially a 3-dimensional map. So you're literally looking at this grid and seeing your 4 different clusters as the machine decided to provide that solution. This also allows you to see the clusters based on the particular cases that are within that clustering solution. And then this is the ultimate visualization of it. Over here, we won't go into this now just to keep the time, but you can change this grid solution depending upon how granular you want to get. If you think about, for example, blood testing with sensitivity issues up front versus specificity, you might really drive for a high level of false positives because you really want to make sure that that blood's clean. Or you may be quite granular in the number of hospitals you're trying to understand, or you may be pulling back and being quite macroscopic. Again, it's a data mining environment for the purposes of exploring as opposed to arriving at a settled solution. So to summarize, just sort of, again, because I'm throwing so much information at you, we've got the initial mapping and a look at the data. From there, we are going to a clustering. What do the users think exists in there? Doing visual inspection of those clusters. Then we're going to the machine learning and giving it a chance. We want to see what its 4-cluster solution looks like compared to ours. We're visualizing that on a grid that allows us to take a look at that. And then we move to a comparison. This is sort of, after all that hard work is done, sometimes that can take 1 or 2 workshops, or it could take a couple weeks of analysis. We get to the actual visualization. What you'll see up here are a whole different series of ways in which you can take a look at this grid by looking at various combinations of information. Once people get the hang of it, this is where we spend the majority of our time looking at what is the data telling us, looking for non-obvious patterns of relationship. I'm just going to show you 2 of them. This first one's the most important because it allows you to take a look at the degree of corroboration between your cluster solution and the machine's cluster solution. So we did a 4-cluster solution. Give this a second here to come up. And what you see here is the numbers represent the cluster that we had here, our 4 clusters, or sorry, 3. Actually, you know what? I just realized I've been running 4 when I should have been running 3. Sorry about that. And let's see, okay, yeah, so we got our 3. And then here we'll run our 3. What you can do then is you can see the color is where the machine put cases, and then the number is where we put cases. Now, I purposely picked a data set that's not particularly great because you can see there's a lot of overlap. Because I hate when people do demonstrations and they provide you this crisp set and it all works wonderfully, and then you use your own data and you're like, that didn't quite look as good. You can see that, for example, down here in quadrant 3, you've got a variety. You've got cluster something from cluster 3, 2, and 1, some 3s. It's a bit distributed. One of the things this suggests then is that maybe we should go back and up our cluster solution. Why? Because it doesn't seem to be fitting particularly great. We can go into the SOM again and try a 4-cluster solution, retrain the results, and then see if that provides us then a better fit. Let's see, we'll go in here. And then you start to see that this might be a slightly better fit now. Now we're getting numbers a little bit better, but not particularly great. And this is this comparison and contrast to looking at the way the machine fits it, the way you fit it. And again, in the real world, things don't quite fit exactly, but it is this give and take of going back and forth. And so we'll work with people to sort of get to a solution that they feel comfortable with. The other important tab, being mindful of time, to show you is what's called the bar plot tab. What's nice about this is if you thought of, for those of you familiar with z-scores, this line through the center is the average across everything. If something's above it, for example, first time in justice system, that means that is higher. If it's below it, as in the case of older adults in social isolation, it means it's below it. It's a nice way of just looking at the profile. And what's really cool about this is we've got the packaging we're using allows you to take a look at individual variables, remove variables in comparison to others. And so you can explore all different combinations. One of the things we oftentimes do to help people understand the data set is we'll start with something simple. In this case, we're concerned with the teen pregnancy. So we'll start here and say, looking at the distribution of the cases, we see over here on this side, we've got some of the lowest levels, and over here we've got some of the highest levels. The thing with this Euclidean approach to geometry is that you should get mirror images of each other, just like in a correlation. You should expect the profiles that look the least like each other would be the furthest distance from each other. And then we can begin to put factors in each step of the way and ask users, is this making sense? Do these profiles work for you? Are we seeing what we would expect? Again, if this was hospitals or areas, in this case within Wales, around deprivation, and we sort of proceed with that. Again, I'm going to keep moving just for the purposes of introductions. But again, you can do a lot of exploration around individual factors and so on and so forth. The next thing that's really important is to then move to the systems mapping tab. So what you have here is, if you recall, we built our systems map. We have a sense of what we think is going on in the data set. Now we're going to look at what the actual data arrived at, its own data-driven solution. So again, you're seeing that throughout complexity, what it's trying to do is get you to think about something and then push it to see if the data agree with it, if the data allow it to make sense. I can't go into too much detail here, again, because of time, so we can have some questions. But one of the nice things is you can pick different types of projections that you would like to look at the data set. And you can set threshold levels for the factors that are included. But this is an important aspect of complexity that you don't get in other approaches. This is an overall mapping of this relationship between deprivation and teenage pregnancy. But what's nice here is you can actually go into the clusters. What we find, for example, around this issue is that in one part of Wales, what accounts for under 18 conception rates may be a different causal flow than what we find, say, in another part of the country. And so one size not fitting all, arriving at multiple policy solutions to a particular problem that you're dealing with. And what's great too is when you're working with folks, this allows you to edit. You can actually get in and change all sorts of things, put in additional variables, explore barriers to change, levers to change. You can do random walks on this network, for those of you who know, which allows you to just explore the degree of linkages, indirect effects, and so on and so forth. The last thing then is you have this simulation tab where actually you can get in and based on all of that sort of study, then begin to make some types of interventions. Again, you see our 4-cluster solution. You see the same profiles that we saw in the beginning, but now you can go in and make interventions. So if you're thinking for the NHS, if you've got these clusterings of different hospitals, say around, again, bed availability going into the winter months, and you can go in and say, well, if we could change this to something, some basic improvement, and then run the analysis again, does that allow for the change that we're looking for? Is it driving in the direction we want to do? Users find this incredibly useful because it's a no fault, no error simulated world where you can play around with. And the last thing to end on time here is you can also do data forecasting where you can explore future solutions. So if you know, say the data last year on NHS beds availability during flu season and COVID season, you can actually take that data and then bring in the data for this year and explore what last year's data teaches you about where hospitals might be ending this year. And again, you get your profiling, you get a sense of where they fit and so on and so forth, so these tags and identifications. And again, with all of it, this final part where you can generate the report allows you to, again, access all of the data that's being collected, the pictures, the whole, so on and so forth in the background. And with that, I will stop.
Thank you, Brian. That was fascinating, and a really excellent walkthrough. And a quick walkthrough. Obviously, something has taken quite a long time to develop and is an ongoing project. So there's a couple of questions on the Menti, but I was just going to say, I was just sort of. So how has it been used so far? You've given us a sort of a couple of examples, like the teenage conception rates and sort of how, and sort of exploring that kind of thing, and healthy weights. So how has it been used and taken forward to a policy that has therefore had an impact, or it's in the process of having an impact?
Yeah, for sure. And just to say, for those of you who your ears might be bleeding after watching that, my students typically, and when you use it, the first time you see a lot of that stuff, for those of you who have never worked with this, it can have that sense of, that's ridiculous, I'm not using that. And I think policy people, to your point, Rachel, a lot of times when I sit down with folks, they look at this and they're like, okay, as you start to look at it, you start to think about things. And so it has had an impact around, say, for example, the healthy eating in Durham County Council, for example, Durham County. One of the things that's evidencing itself as far as policy goes is that towns with a sort of the old castle town center with high access to fast food, the obesity that is emerging amongst children, as opposed to areas where you don't have the castle town downtown center road. And so the question is, you're still getting obesity rates. So is it simply access to fast food, or is something else going on? And that,
Yeah.
but here's the key: is it is about access to fast food in those towns, but in towns where that's not happening, that's not what's going on. So the question is, why are the obesity issues there? Sedentary lifestyle, using cars as opposed to the bus, kids not getting out and exercising, kids in Centertown access to public transport, but they're eating a lot of the sweets and the super carb foods and stuff. So policy intervention over here isn't the same as policy intervention over here. And those are the kind of non-obvious insights, as just a simple example, that this sort of approach can. And the other one we're doing is around resilience up in Scotland right now. We just wrote a grant around polycrisis, NHS resilience in the face of polycrisis.
That's interesting, and I really like the way that you can. I mean, I thought it was quite clear how you sort of stepped through the app, but also, yes, you can see people will be sort of overfaced by something, and sort of may have to do that translation of how they can use it for themselves or interact with it. I thought I really liked your walkthrough. I thought it was great, and I really like tools which allow users to have sort of visualize what is the mapping out of the system with things that they recognize, and they can kind of relate to it and sort of interact with it in that they can just sit there and say change that, or I think that's too high, and I can see that as being valuable as well. I'm going to jump to the Menti questions because there's been a couple. I'll just share my screen, even though I do know that people can see them as they enter. If they're on Menti, they can see them themselves, and if anybody's got their hands up or want to speak from the room as well, by all means do that. So the first question we just talked about, but it's really, I suppose, taking that a bit further, of the examples that you gave, are there any sort of particular areas or topics where this would be most useful for, or is it really just up to your imagination? What have you got data for? What's your area of interest?
I think it's most useful when trying to find the most parsimonious factors that account for something isn't doing the job.
Yeah, okay.
That's really when I think this is useful. My colleague Lasse Gerrits, who I wrote the book with, he wrote a book because he's in policy and urban planning. It's called Punching Clouds. And he said there's lots of policy interventions. Yeah, you like that? There's lots of policy interventions that are pretty straightforward. Probably lots of things within the NHS that they're basic. We don't really need to use something like this. It's not a panacea, but when you get into situations like resilience, NHS resilience across, a wide and extensive system where you're trying to really understand differences and nuance, that's where this becomes useful. Because even though it is squarely positioning itself within complexity, it is, ironically enough, trying to simplify it. To make it accessible. So really, that would be the answer, is when you're feeling that the methods you're using are not getting you the solutions you're looking for or the insights that you're trying to get at.
Now that's interesting, and I think having that sort of way of explaining it to people, as opposed to people generally understanding that the relationship between A and B is this. Well, actually, yes, A is true on average, but if you actually look at the differences in locations or different places, and then having that sort of sensitivity will give people more confidence, because we know that these approaches, generally speaking, often are not having the impact that they want, because they're probably applying the same solution across the board, and the average isn't working for a lot of those situations where it's locally sensitive or sensitive to particular cohorts. Now that's really, I can remember that. I can see that as being a really useful and something I haven't seen before in this way as well. So I'm just looking again at the questions. Thank you for that. So there's one here saying that who can use the app? Who's it available to? Is it anyone? Is it
everybody? It's free. It's free.
Tout le monde.
Tout le monde.
Yeah. And that's it for my French. So don't speak back to me in French, because I'll just go all blank.
I mean, we purposely wrote it in our studio, put it as a Shiny app, and host it on our Shiny, because we want people to access these things. for those of you who actually work in R, you can, as you saw, there's a downloadable version. And the other nice thing about it is it's quite bespoke. So if you wanted to get rid of certain tabs, or you wanted to add tabs, or you have somebody that works in R, you can really make it quite bespoke for what you're doing. And we've done that in a number of instances.
We've got quite a few people in the strategy unit who are who use R all the time, so and I can see that this applied to various sort of projects and problems that we sort of arise all of the time. I can see this has been an extremely useful tool. Okay, so thank you for that. This is really an early Christmas present, so I'll certainly be sharing the recording of this and some of the main points with certain people. Oops, okay, goodbye. So there's a question here around. I've just I think I might just have accidentally come out of Menti, so I can remember the question, and that's fine. The question was around using your own data and considering IG.
What is IG?
So information governance, which I would have thought, I suppose that is just about you using data appropriately in whatever setting.
So, so the Shiny platform, it wipes everything clean. There's no data decay, no delay, no ghosting. It's some people see that as a problem, because it means once you're done with your analyses, you have to download them, and you can re-upload, your solutions, but it is absolutely wiped clean every time. You can go on to our Shiny, and you can see their data security, data governance statements.
Okay,
that was another reason we went with this, was we didn't want to be connected to the Microsofts of the world or anything like that.
Okay, that's a commendable approach, I would say. So I'm just reloading my Menti. Something strange happened just then. But if there's any, while I'm doing that, is there anybody in the room? Is Mohammed or Jen? Have you got anything you'd like to?
It's good timing, Rachel, because you hadn't actually, because I put a question in and
I read your question.
You haven't read it yet. Unbelievable.
Well, what happened was I thought that's Jen's question. I'm going to totes ignore that one.
Well, I think I would just like to quickly say, I think it's really interesting what Brian and colleagues have been doing. I've put in the chat, but for those of you who haven't, I think that the CCAN resources are really, really helpful. I think the PRSM tool is something that lots of people can use for as a way of kind of trying to get causal loop maps or complex systems maps together, and there's some really useful tools for complexity on there, for complexity and evaluation on there too. But I think that there's some of the reasons why we're having these conversations in the first place is because I think the strategy unit's really interested in mixed methods stuff, complexity stuff, as a really key way to help understand and unpick these really tricky policy problems that we've got. But I think that is quite difficult because of the worldviews, Brian. People that getting people to kind of communicate, agree and understand the research approach, like the policy people, but also the people who understand enough about the algorithms, and also the people who might be quality researchers who want to see the world kind of that contextual experience that you talked about at the beginning. It's a real strength of this type of approach, but it's also quite difficult in terms of getting people to align and communicate. I suppose I'm interested in what your view is on how you can kind of get people together and bought in at the outset for this type of work.
That's a great question, and I don't have the perfect answer. There's been a lot of failures as much as there's been successes. We've had situations where, we've gotten with folks, they're quite keen on this, and then it goes up the administrative ladder and they're just not interested. So it's not, it's life. But what I have found is useful is and again, this is an open offer, is to run workshops. And if I'm in the room, or say, yourself, if you've learned complexity and you're like, okay, this is cool, and you're in the room, and really help walk people through what's going on, give them a chance to come back to it, that helps. And it's been 2 instances where I was in a situation where the the junior colleagues were quite keen on the thing. The senior colleague was there, the policy person, and the person wasn't buying it. And then we ran the algorithm, and it found an error in their large data set because it's machine learning, and it went right onto that. And they were like, "Oh my God, we've been making decisions, and this is wrong." And the boss was like, "I like this." so I think it's really to me now, to go on the opposite side. I feel like all of you are just 10 minutes late to the next thing you have to do. So I really think that if I'm not answering your remit, if I'm not providing you insights that you don't already have, I'm going to lose credibility pretty fast. So I think we've really built this to be useful, and it should be useful. And if it's not giving you useful results, then it's probably not the tool for you. So we try to be very pragmatic that way. It's not a sales pitch. It's really about, but as having said that, I generally find 80% of the time people are interested in this if they can set aside time to learn how to engage it. And again, workshops are quite useful for that.
Yeah, thank you. Thanks very much, Brian. And so we've hit 12 o'clock, and so I'm renowned for sort of finishing on time-ish. So I will draw us to a close. So I'll thank you again, Brian, ever so much for coming and sharing that with us. I do hope you're open to people contacting you after today's session, because I think they'll probably want to, if that's okay. I mean, that was you can't say no because it's all being recorded and there's lots of people watching. You might be thinking, no, don't you dare. But yeah, thank you so much. Obviously there's it clearly is an extremely useful app in the right context, and building those relationships for people to invest their time in learning it and using it is obviously part of that process. So I'm just going to sort of finish it. Thank you again for coming, and I'm just going to finish off with just sharing with people what's coming up in the next couple of huddles. So we've got a next session on risk stratification and segmentation. That's with Stephen Wyatt. And then after that, we've got Sam Riley from NHSE. She's the director of Making Data Count. That's in February. And I keep putting on here a hacker presenter. So there's one or two hacker presenters that want to come and join us, and we just need to make that space for them. And then just finally, we have a couple of training opportunities coming up for you. So the strategic decision making, that's in February. We've got some introduction to R and Shiny relevant to today coming up soon. The understanding and reporting hospital statistics was yesterday, and it was excellent. So sorry if you missed that. So make sure you join next time. But what things that you haven't missed is the failure parade. So this is your failure might have been in your work. It might have been that you didn't engage well enough or with the right people at the right time in order for a project to flourish. And so we're basically pulling together everybody's failure. And it might be that your approach was wrong, your question, but whatever it is, we know that people learn from failure, and we want you to be able to share your examples of where you think people can learn from. And that's a free joint webinar with the HDR Midlands, and that's in January. So please do look out for how you can get involved with that. We've got analytics for leaders. Again, same day in January. That's with Mohammed, and also we're just finalising a date for the improvement science, and so dates for that are coming soon. So I'm just coming back to the room. So thank you. I'm going to stop sharing, and I will say thank you again, Brian. Lovely to meet you. I'm going to go back to your website now and see what else I can distract myself with, and thank you for that. And hopefully we'll be back in touch, because I'd love you to come back.
Yeah, that would be brilliant.
Thank you. And thank you everybody else for coming. We'll see you. If I won't see you before Christmas, have a great Christmas for those who celebrate Christmas, and those and I'll see everybody after Christmas anyway. So bye for now. Bye.